Hello everyone, welcome to Learning Techniques. This is your host Hemant Gangwar, and today we are going to discuss about the Logical Volume Manager or LVM. This is one of the widely spread used topic in Linux for the storage management and is hugely used. So in any day or two, you will need these type of commands to manage your storage devices. Those who are totally new to the LVM, it actually provides you the capability to increase or decrease your file system. Obviously, if the file system permits that. So increase is on the fly, but decrease is not like that. But still, it is achievable and possible with the zero data losses if you are performing it carefully. In this discussion, we are only going to create one and increase one. So let's proceed. The very first component of it is physical volume. In a layman term, it's simply a disk or a partition of a disk, which is understandable or readable by LVM. So quickly move to a ESXi box and add some disk to perform the testing. This is the virtual machine. Let me quickly add two hard disks. Okay, and one more. Okay, what errors I'm getting? Okay, it's not able to find the storage size. Just give me a second and let me see how much storage capacity I have. I have 6 GB. So adding a storage should not be a problem. Still just to be error free, and okay, now it's showing that we have 6 GB capacity available. Okay, so quickly save them. Now move to a putty session and have a look on the storage available with us. So you can see that two new disks are added to the system. There's SDB and SDC. So I told you that either you can use a complete disk or you can use a disk partition. So first create a partition on one of the disk. The command will be fdisk. Quickly create a new partition. Okay. And that will be primary. Partition number is 1. First sector is fine. And let's give me the size of 500 MBs. Okay, I can see the table through P probably, and it's fine. Change the type to Linux LVM. It's 8E, and it's fine. Now save it and make it or update the partition table basically. Okay, so we can see we have two disks, one with a partition and one a complete whole disk. That is div SDB. So first, let's bring into the LVM control. So that to bring it up, basically made it a physical volume. So the command here is pv create. So we can try giving the complete disk and the partition of the disk. Okay, so it has created two physical volumes for us. If you want to see the small summary, you can give a PVS or you can use a PV display as well. So it will show you the size of the PV and how much space is left in that. So those are the new ones. So they have all the spaces free. Now, the second component that we need to discuss in this aspect is our volume group. Volume group is nothing but just a pool of the physical volumes. If you don't want to reside or just to depend on one of the disks, you can make multiple physical volumes and then bring it aside a pool so that if you have 5 disks of capacity 100 GB each, you are able to create a complete file system or a mount point of 400 plus GBs. You don't have to be restricted with the disk space of an individual disk. So creating this is also very easy. And the command for that will be vg create. I'll perform with one disk only. So the name of the VG which you want to give, I'll give it a demo VG and the disk name. So I'll give SDC1. Now we have a VG created. We can check it through VGS. Now in the future, you want to increase the VG size. So that's very easy and you can perform a VG extend, or we can perform that later if required. Let's move with one disk only. Okay, so now the third section, that is the topmost layer of it, is logical volume. So It's just basically a partition type of schema. You don't have to do much. Only these are the logical partitions, as the name suggests, and they resides over your volume group or your pool. And depending on the size of these logical volumes, you can separately mount them and use them as different storage paths for yourself. So to create it, the command is very easy. That is a lv create, and the only thing, only gotcha you need to take care about this is you should have enough space in the volume group to create a logical volume of that particular size. Now, what that means is, since you have 496 MB of free space in your volume group, you cannot create a logical volume more than this size. If you want to create that, you have to add some extra physical volumes to this volume group. So let's create a new logical volume, -L. We can give a space and or the disk size and absolute values. So let me provide the disk space as 300 MBs. Then -N flag that allows you to provide a name of your logical volume. So let me provide a name as demo LV and the volume group name from where you pick the storage. So you have a demo LV created. You can run a command like LVS or LV display to see whatever LV is available with you. Now you have a physical volume, a volume group, and a logical volume created for you. So the next step is to make it mountable. So for that, we need to first format with a relevant file system. Those who don't understand formatting, it simply means making your disk block or the partitions aligned to your OS strategy so that the data can be written or readable or writable over it. So this is Red Hat 7. So it supports both ext4 or XFS. So I'll go with the latest one and XFS. So now the complete path of your storage device. Dev with the device name, then the volume group name, that is demo VG, and your logical volume, that is demo LV. Now we have created a file system over it. But if I see a df-h, I am not able to see the TAT storage. So now you have to temporarily mount it or permanently mount it, depending on how you want to use that. Let me use the free mount point MNT. Now, if I see the df-h of MNT, I can see I have around 282 MBs of space where I can write or read data. Now, the thing is, in case I'm short of this space and I want to extend the size on the fly, obviously. So LVM also supports that. So first, see how much space we have. We have like 196 MBs. And in case you need like 500 MBs of new space or extra space, obviously at this point, it's not possible. You have to increase the size of your volume group. So now let's first see if we have any free disk available of free PV available. So we can see we have one PV available, that is DevSDB, which is yet not attached to any of the volume groups. So we can use that, and it has around 1 GB space. So let's extend our volume group. The command to do that is VG extend and your VG name and the PV which you want to add. So now the physical volume is added to a volume group. And if we see both the outputs, first the PVS output, we can see this, my storage or my physical volume is attached to this, the part of this pool that is demo VG, and it still has 1 GB approximately of its space completely free. So you can also see in which PV you have how much space available or free. Now, if we go to VGS, you can see that now we have around 1.2 GB of space free. So if we need 500 MBs more, we can use that. So if we go with the LVS, I can see it's still 300 MB. So let's extend its size. You can notice that my mount point is still mounted. I'm not unmounting it. So if you're doing any work at the back end, it won't be hampered. So to extend it, we have to use the command like lv extend, and there are two options. Either you can give capital L or small l. Capital L takes this space in absolute size, while the small l extends the default value is the chunk of 4 MBs. So if you want to add like 50 MBs, which is not divisible by 4, you will get an absolute size of around 52 MBs. So even if that doesn't make sense, that's fine. Plus how much size you want to add. So I want to add like 500 MBs and the name of my logical volume name. So dev demo VG and demo LV. If I use a -r over here, that will actually skip my next step, but I want to show you everything. So I'm not doing that. So you can see that my logical volume size is extended and it's now 800 MB of size. So but if you notice, my MNT is still of 300 MBs. My file system is still not extended. In order to extend the file system, you have to use the file system specific commands. That this is XFS, so we can use XFS growfs, and then your disk name or the disk path basically. It's increased. Now, if you use a df-h MNT, you can see it's like 800 MBs approximately. In the same command, if you use -r flag, you don't have to perform that XFS growfs or resize to FS steps. So that would have done automatically the part of that. But still, try avoiding the short commands. Try to go by step to avoid doing any errors. So that's all from my end in this. That's not a very Herculean task. It's an easy to follow video or easy to follow topic. Do follow that. There are a lot of huge scenarios. Practice those and let me know if you have any queries on that. So